All right, today's lesson is properties of transformations. So it says which transformations are rigid motions and what does that mean again? All right. Translation, rotation, and reflection are rigid motions. Okay. Rigid motions preserve angle measure and side length the image is congruent to the pre-image. All right, so what transformation is not rigid? Dilation is not a rigid motion. Okay. All right, so now let's go through some properties of rigid motions and how things work. So given triangle STW and BFN is congruent to triangle BFN, find each missing measure. So when our shapes have been moved around, sometimes it's difficult to see what corresponds with what. So what you want to do is take this information, which is our congruency statement, and you're going to want to line up those letters. So I'm going to take S, T, W, and B, F, N. And if the statement is given to you, it is guaranteed that S corresponds with B, and T corresponds with F, and W corresponds with N. So if I kind of go ahead and go back to my pictures here, S corresponds with B. So I'm going to put squares around those. And then T, so I'll put a circle. T corresponds with F. And then I'll do triangles. W corresponds with N. And so why is this helpful? Because then it's easy to see that BN corresponds with SW, or BN square to triangle, SW square to triangle. So if BN is the same as SW, well, SW is 9, so BN must be 9. Okay. So TW is the same as FN, so FN. And so TW, how long is that? Well, it's the same as FN. How long is that? 14. And then our last set of corresponding sides, I have ST and BF. So ST is equal to BF, which is equal to 17. Now, angles are even easier because then it's just lined up perfectly. I'm just going to go ahead and erase a few things out of this crazy little lineup I did. There we go. So angle W corresponds with angle N, so the measure of angle N, and then the measure of angle B corresponds with the measure of angle S, and the measure of angle F corresponds with the measure of angle T. So notice I'm just lining things up, right? Finding my correspondence that way. Now I can go back to my picture. Well, let's see, S is 67. So that means B is also 67 degrees, right? B is also 67. Oh, I can see that N is 82, so this one's 82. Well, both F and T have no angles, but guess what a triangle has? 180 degrees, that triangle sum. So I'm just going to add my two numbers together. I get 149. I'm going to subtract that from 180, and therefore the measure angle F is going to be equal to 31. All right, so that one goes through the whole entire shape of having 3 sets of corresponding sides and 3 sets of corresponding angles that are congruent to each other, because rigid motions maintain angle length and side length. Angle measure and side length, pardon me. All right, so now this is a regions question. It says in the diagram below, triangle CAR is mapped onto triangle BUS after a sequence of rigid motions. So once again, the reason why I line them up is so I can see who corresponds with who. All right, AR is 3x plus 4. And AR corresponds with US. So sometimes what I do is I go AR with a squiggly, US with a squiggly. Okay, RC is 5x minus 10. Now I keep labeling these pictures. CA is 2x plus 6. And then SB is 4x minus 4. Wait, what's the length of SB? SB, ooh, SB, BS, has to be the same as CR. So SB is corresponding and congruent to CR based on this. So I can write SB equals CR. Then I'm going to throw the expressions in. SB, 4x minus 4 equals 5x minus 10. Now I need to solve correctly. Remember, deal with variables on both sides first. So I'm going to take away 4x's on each side. X minus 10 equals negative 4. Add 10 to both sides, which means x is equal to 6. But it doesn't say what's the length of x. It says doesn't say what's the value of x. It says what's the length of SB. SB is going to be 4x minus 4. So 4 times 6 minus 4, which is 20. Okay, so be careful about what is the prompt asking me for, because notice how choice 1 is the value of x. All right, let's keep going. All right, another regions question. Here it says the image of ABC after rotation of 90 degrees clockwise is DEF. So A, B, C, D, E, F. Which statement is true? Okay, BC. BC is going to be congruent to EF. Oh, this one's false. Okay, so I'm using my lined up letters to figure out what's going on. Erase. AB is congruent to DE, not DF. This one is false. So now we're down to our last two, and it's just corresponding angles are congruent. Once again, line things up. Is C equal to E? Nope. But is A equal to D? And the answer is yes. So I don't have to rely on my ability to rotate to get this answer right. Hopefully we would be able to see, like if I go from angle A to angle D, you guys can see that's a nice little 90-degree angle. All right, question number 4. Triangle ABC is translated 5 units to the left and 2 units up to map onto PQR. Which statement is not always true? All right, well, the first thing says I'm going to do this. A, B, C, P, Q, R. So the first thing says triangle PQR is congruent to triangle ABC. Well, this is guaranteed to be true because translation is a rigid motion. Then it says angle A is congruent to angle Q. That's a maybe. I don't know. Are A and Q, they're not lined up. It's not guaranteed to be true. So that's not always. I mean, I guess if I had an isosceles triangle, maybe it would work, but it's not going to work on this picture. Then it says BQ is radical 29. I don't understand what that means. Then it says RQ is equal to BC. Okay, this one's true. All right, so right now we have 4 is true and 1 is true and 3 is something I don't understand. So the problem with multiple choice, if you just go ahead and circle the one you don't understand, you've now decided that you're not going to bother trying to figure out the right answer. Let's figure it out. Okay, let's go back to the beginning. ABC is translated 5 units to the left and 2 units up. So A, 1, 2, 3, 4, 5, 1, 2. That's going to be point P. B, 1, 2, 3, 4, 5, 1, 2. Here's Q. And then C, 5 and 2. Here's R. All right, so here's our image triangle. BQ. B, the length of BQ. This segment from here to here is radical 29. All right, so we haven't 100% gotten to this, but this thing that's BQ is essentially what's called a vector. If I were to connect any two corresponding points, watch this, C to R, check this, A to P. Do you see how I've just drawn myself a nice little three-dimensional prism? But basically, all of those purple lines have the same exact length, and they're heading in the same direction, right? So every point is moving along this vector. It's going in this direction, every single point. So now the question is, how long is that vector? Well, I'm just going to go ahead and take that vector and move it over here. So it did this. It went over 5 and up 2, right? And so here's the vector. And you can see that it's the hypotenuse of a right triangle, or C. And then this leg is called A, and this leg is called B. And that, my friends, is good for the Pythagorean theorem. So A squared plus B squared equals C squared. I've got 2 squared plus, the distance of B is 5 units. 5 squared equals C squared. 4 plus 25 is equal to 29, which is equal to C squared. So C is equal to the square root of 29, or the length of this vector is equal to the square root of 29. So although it's not something that we talk about often, another way to talk about translation is a vector, and this is true. So because we don't necessarily know this, like specifically in this one, certainly angle A is not the same size as angle Q, because Q is a right angle, but these are not corresponding angles. They are not guaranteed to be congruent. So the correct answer to the question 4 is 2. All right, so now, the last thing that's written here, it says a translation displaces every point in the plane by the same distance in the same direction and can be described by using a vector. So there's your definition of what's going on. That's what BQ is. Sometimes you can see notation that looks like this, BQ, and then it'll have like this like kind of thing that looks like a ray, but it's not a ray. That's a vector symbol. All right. The last page of our notes is about properties being preserved. And so we're looking for the things that stand out. So distance is the same idea as side length. And so since the first three are rigid motions, distance is preserved, distance is preserved, distance is preserved, but distance is not preserved for dilation. So that's a no. And the deal is no matter what, even if k is equal to 1, when k is equal to 1, the shapes are congruent, but we say that the corresponding sides are still proportional, okay? So I'm going to say no when k doesn't equal 1. That's when they're not going to be congruent.
Good afternoon. If you have a one on Chromebook, please set it before you leave. Buses leave at 2:10 this afternoon. Zone 4, you're now dismissed.
All right. Corresponding angles are congruent. That is preserved across the board. Notice that vertical stretches and horizontal stretches are not on here. That's because the stretches are not considered to be true transformations. Our true transformations are translation, reflection, rotation, dilation. Parallelism. So parallelism is corresponding sides are parallel. So it's yes for translation, and it's yes for dilation. It is not a guarantee that it would be true for reflection or rotation. All right, orientation. So that's the organization of the letters. And I'm just going to go to this one where we have reflection A.
Zone 3, you're now dismissed.
So here, A, B, C, the direction of the letters is in clockwise, going around the shape. But when I reflect, I get A prime, B prime, C prime. What's farthest away on either side of the mirror is farthest away. So now we go counterclockwise in naming. So orientation is a no for reflection. It is okay, or it's preserved for the other three. Now, basically for these last two, if you have congruent shapes, other measurements will remain congruent. So the idea of perimeter area, these are going to stay the same for any rigid motion. So rigid motions are rigid motions, but when you dilate, perimeter and area will change. So now what you want to do
Zone 2, you're now dismissed.
is focus on the nose. Distance is not preserved here. Parallelism is not preserved here and here. Orientation is not preserved here. And size is not preserved. That perimeter and area is not preserved because it only is preserved if k is equal to 1. We got to look at a few Regents questions where we have a scale factor of 1, how we deal with that, but that is the last part of when the scale factor is 1. We can say it's both congruent
Zone
and
1,
similar.
you're now dismissed. And if you have a one on Chromebook, please return it to the main office before you leave. Have a great day. We'll see you tomorrow. Just a reminder, buses leave at 2:10 this afternoon.
All right, so there is your information about properties. Please go ahead and move on to the homework assignment and complete that work for homework.